Quantum computing is rapidly emerging as one of the most disruptive technologies of the 21st century. Once limited to theoretical physics, quantum computing is now at the center of global competition, shaping the future of national security, economic power, and technological dominance. As global powers race to achieve breakthroughs, quantum computing has become a new geopolitical battleground. Unlike classical computers, which use bits that exist as either 0 or 1, quantum computers rely on qubits. These qubits can exist in multiple states simultaneously, enabling quantum machines to process vast amounts of information at unprecedented speeds. This capability gives quantum computing the potential to revolutionize fields such as cryptography, artificial intelligence, drug discovery, climate modeling, financial systems, and military intelligence. One of the most discussed milestones in this race is quantum supremacy. Quantum supremacy refers to the point at which a quantum computer performs a task that no classical computer can realistically achieve. While largely symbolic, it represents technological leadership and signals strategic advantage. Nations that achieve quantum supremacy gain not just prestige but influence over future digital infrastructure and global standards. The United States is widely regarded as a leader in quantum computing research and innovation. Strong government funding, elite universities, and powerful private sector involvement have created a robust quantum ecosystem. American tech companies are developing advanced quantum processors, cloud-based quantum platforms, and quantum software tools. From a geopolitical perspective, quantum computing is viewed as essential to maintaining technological superiority, protecting national security, and securing military communications. China, however, is seen as the most serious challenger to US dominance in quantum technology. China has made quantum computing a national priority, investing heavily through state-led programs. Its strategy focuses on long-term planning, integration of civilian and military research, and rapid scaling. China has already demonstrated advanced quantum communication systems and has invested in quantum encryption and satellite-based quantum networks. These developments suggest a strong focus on secure communications and strategic resilience. Europe has adopted a different approach to quantum geopolitics. Rather than competing as individual nations, European countries are pursuing coordinated research through large-scale public funding initiatives. Germany, France, and the United Kingdom have established quantum research hubs focused on hardware development, talent training, and industrial collaboration. Europe's strength lies in foundational science, regulation, and ethical governance, although challenges remain in commercialization and global competitiveness. Other countries are also positioning themselves in the global quantum race. Japan and Canada have strong academic research programs and partnerships with industry. India has launched national missions to develop indigenous quantum computing capabilities, recognizing quantum technology as critical for digital sovereignty, cybersecurity, and economic growth. These efforts highlight how quantum computing is no longer limited to a few superpowers but is becoming a global strategic priority. The geopolitical implications of quantum computing are profound. One of the most immediate concerns is cybersecurity. Powerful quantum computers could potentially break existing encryption systems, threatening banking networks, military data, government communications, and critical infrastructure. This has triggered a parallel race to develop post-quantum cryptography as nations seek to protect themselves from future quantum attacks. Beyond security, quantum computing could reshape global economic power. Countries that lead in quantum technology may dominate future industries, control intellectual property, and set international standards. Quantum advantage in areas like logistics optimization, pharmaceutical research, and financial modeling could translate into long-term economic dominance. At the same time, quantum geopolitics is marked by increasing competition and fragmentation. Export controls, talent restrictions, and technological decoupling are becoming more common as countries seek to protect sensitive research. While international collaboration remains important for scientific progress, strategic mistrust is reshaping how quantum knowledge is shared. So, who will dominate the future of quantum computing? There is no clear winner yet. The United States leads in private innovation, China in state-driven scale, Europe in coordinated research, and emerging economies in strategic ambition. What is certain is that quantum computing will redefine global power structures.